Have a nice day everyone. I am Purni Nanankara. My research is to find out an effective iron removal method for iron-rich groundwater. Groundwater is a major source of drinking water all over the world. Iron can be easily found in groundwater since iron is the fourth most abundant element and the second most abundant metal in Earth's crust. High iron concentrated groundwater can be observed in Gambha, Puttalam, Kalutara, Matara, Galle, Hambantota and Kataragama areas in Sri Lanka. This is a picture of a shallow well with high iron concentration located at Thammita, Gampaha, Sri Lanka. Presence of iron in groundwater cause health issues and also aesthetic problems such as bad taste, bad odor, discoloration, deposition in pipelines, and it generates high turbidity. According to the SLS standards, the maximum recommended iron concentration of potable water is equal to 0.3 milligrams per liter. In such a manner, iron in water needs to be removed or reduced to an acceptable level. The objectives of this research is to optimize the iron removal method using oxidation, flock formation and filtration to find out the best flock forming chemical out of alum and polyaluminium chloride, to find out the optimum coagulant dosage, to find out the optimum pH range. Moving on to the methodology, first step was analysis of groundwater quality, second step was aeration, third step was coagulation, flocculation and sedimentation process. I did aeration process using a bubble aerator and the coagulation, flocculation and sedimentation process using a jar test apparatus. As the first step, I did analysis of groundwater quality. There were no any other matter needs to be removed or reduced other than iron, color and the turbidity. Secondly, the aeration process. I checked different pH levels. Best pH level was observed as 8. Third step was coagulation, flocculation and sedimentation process. Alum and polyaluminium chloride were used as coagulant. Different coagulant dosages were checked in different pH levels and observed the iron removal percentage to find out the best chemical. This graph shows the iron removal percentage using alum and polyaluminium chloride in different pH levels. Red color represents the polyaluminium chloride. The coagulant polyaluminium chloride shows positive results over coagulant alum in all checked pH ranges. Hence, the behavior of coagulant polyaluminium chloride in coagulation, flocculation and sedimentation process was further observed to find out the optimum coagulant dosage and the optimum pH level. This graph shows iron removal percentages with different polyaluminium chloride dosages in different pH levels. Let's move on to the conclusion of the research. Best pH range for oxidation is observed as 8, maximum removal percentage recorded as 33%. Moving on to the coagulant alum. When using alum as the coagulant, maximum removal recorded was 2.13 milligrams per liter to 0.98 milligrams per liter. Since 0.98 milligrams per liter is larger than acceptable limit, it can be observed that iron in groundwater can't be removed efficiently using alum as the coagulant. It was observed that flock formed during the flocculation is thin and smaller in size. Hence, large settling time is required for settling. This is the possible reason for less iron removal when using alum as the coagulant. In future, it is recommended to do repetitive using alum and polyaluminium chloride to increase the reliability level of results. Further, iron concentrations up to 8 mg per liter are found in National Water Supply and Drainage Board groundwater treatment plants. Therefore, it is suggested to extend the research to initial iron concentration levels up to 8 mg per liter. Obtained results can be directly applied in real-world water treatment plants in larger scale. These are the references I used. Thank you.